Well, hello students, welcome back to Mathematics class with me, Mr. Alfie. In this video, we're going to learn about multiplication in matrices. Let's check this video out. Multiplication of matrices. There's two types of multiplication of matrix. The first is multiplication of matrix by a scalar and multiplication of matrix by matrix, or we also call it multiplication of matrices. Let's discuss the first one, multiplication of matrix by a scalar. If K is a scalar, then the scalar multiplication of a matrix A by K, denoted by Ka, is obtained by multiplying every element in A by K. Let's the element of matrix A are A, B, C, and D, and K is a scalar. Then K times matrix A is multiplication between K with every element in A. So K times A, K times B, K times C, and K times D. Let's jump to the example. If A, the elements are listed here, 1, -2, 8, 12, -3, and -4, find 3A and -1 per 4A. Let's deal with 3A first. 3A, it means 3 times matrix A. It 3 times every element in matrix A. So matrix 3A is matrix 3 times 1, 3 times -2, 3 times 8, 3 times 12, 3 times -3, and 3 times -4. You just simply multiply 3 with every element inside A. So matrix 3A is 3, -6, 24, 36, -9, and -12. How about -1 per 4A? The scalar is -1 per 4, so you just need to multiply -1 per 4 with every element in matrix A. So you multiply -4 to each element, you will find that matrix -1 per 4A equal to -1 per 4, 1 per 2, -2, -3, 3 per 4, and 1. How about addition we mix with multiplication of scalar, like this example? It is given that matrix A, the element listed here, and B, the element listed here, find 2A plus B. So there is a multiplication scalar here, and there is an addition. So we need to deal with the multiplication of scalar first. So we just need to multiply 2 with every element in A, because we are going to find 2A, and then you plus with element of B. So 2 times 2 per 5 times -1, 2 times 3, and 2 times -5. You'll find 4 per 5, -2, 6, and -10. And after you multiply 2 with element in A, and then you add with B, and then you will find that matrix 2A plus B equal to 0, 3, 14, -17. How about multiplication scalar mixed with subtraction? It is basically the same way with addition. You just need to deal with multiple first. So you have to multiply 4 with A and 3 with B. It means you multiple 4 with every element in matrix A, and then 3 with you multiple with every element in B, and then the product of this one you subtract it with the product of this one. So find this matrix and then subtract it with this matrix. You'll find that 4A minus 3B equal to -4, 41, -31, 15, -50, 24. Well, how about multiplication of matrix by matrix or multiplication between matrices? There is condition that two matrices can be able to multiply. Let's talk about that one. Let's A and B are matrices with the order of A is M by N and the order of B is P by Q. M represent the number of row and N represent the number of column of matrix A. P represent the number of row and Q represent the number of column for matrix B. A and B are able to multiply if the number of column from matrix A equal to the number of row at matrix B, or N must be equal to P. If the number of columns from the first matrix equal to the number of row at the second matrix, so those two matrices can be able to multiple. And then the order of matrix AB is M by Q. M is comes from the number of row at the first matrix, and Q comes from the number of column at the second matrix. So AB, the order is M by Q. Let A, B, C, D are matrices. We know that the order of A is 2 by 1 because in matrix A there are 2 rows and 1 columns. In matrix B the order is 1 by 2, 1 row, 2 columns. In matrix C is 2 by 2, 2 rows, 2 columns. Matrix D is 3 by 2 because there are 3 rows and 2 columns. Let's check. Are A and B are able to multiple? We knew that the order of matrix A is 2 by 1 and matrix B is 1 by 2. Since the number of column in matrix A equal to the numbers of row at matrix B, so A and B are able to be multiple. And the order of matrix AB is 2 by 2. It comes from these numbers and this number. How about B times C? Are B times C able to multiple? Let's check it out. We knew that the order of B is 1 by 2 and the order of C is 2 by 2. Since the number of column in matrix B equal with the number of row at matrix C, it means B and C are able to multiple, and the order of matrix BC, B times C, equal to 1 by 2. It comes from this number and this number. How about matrix C times D? We knew that the order of matrix C is 2 by 2 and matrix D is 3 by 2. As you can see here, the number of column in matrix C is not equal with the number of row in matrix D. That means C and D are not able to multiple, so we cannot simply multiple C and D. But if C times D is not able to multiple, how about D times C? We know that the order of D is 3 by 2 and the order of C is 2 by 2. So, since the number of column in matrix D equal to the number of row in matrix C, so DC are able to multiple. And the order of matrix DC is 3 by 2. It comes from this number and this number.